Okay, so good evening, everyone. So let's start today's session, and let me cross check if I'm audible or not. Yes, this is okay. Okay, I'm audible. Okay, so now we can go ahead then. Just a minute. Okay, great. Okay, as you know, this is a part of Foru 5 series, and for this good evening, and this is part of this particularly I'm discussing the strength of material portion for XC. And so today again we are going to discuss a few more questions, and those questions today I have taken from one topic that I have already discussed in one of the session earlier also, but to have better clarity, more clarity on that particular topic, because very regularly questions are framed from that particular topic, and sometimes you find it difficult in terms of like interpretations. So that is why I have taken one. I'm going to take this session based upon that only. So it is basically related to your that complex stresses portion. Okay, so I'm going to discuss the questions based upon the complex stresses, and for that if some of you have attended earlier sessions, then I had discussed about the how we are going to find out the principal stresses, normal stresses, principal stresses, and the shear stresses in any particular plane, right? And for that, these were the diagrams that I had drawn, and so this was so depending upon how we are taking the direction of these normal stresses and the shear stresses. So in any particular plane, when I want to find out the shear stress or normal stress, then it is going to be handy. For example, when I had said over there, okay, I am applying a normal stress, let us say tensile in nature, and let us say if I want to find out the normal stress on any plane inclined at theta, but with what? With the plane on which you are having the this sigma x is acting. So from that plane, if angle is theta, and if I assume the direction of tau away from this angle, and then this taking this normal stress as tensile in nature, so I'm having this value of normal stress. That is how much stress is you're going to have over here this way, and theta importantly from where you are taking. At the same time, since I had considered it as a tensile stress, so I need to consider, and also over here sigma x and sigma y I had taken while we derive that equation, that particular relation, we take them tensile. So, but in this equation, depending upon what is the nature of these stresses that you need to input, any of them is compressive, then you need to take the value of the compressive stress here as negative, tensile, positive. That is one thing that you have to remember. And if it turns out to be positive, then it means it is going to be tensile only. But if it turns out to be negative, it means this is compressive at this particular plane. Instead of that, it is going to be compressive with this value turns out to be negative. That was the thing. And same way, you're going to have the shear stress that you can get it for over here. If shear stress comes out to be positive, it means the value of the shear stress acting on this plane is going to be in the same direction. If it turns out to be negative, it means the direction of the shear stress will be on the other direction. That is how the interpretations are. Now, this was the case when you are having biaxial state of stress. You are having these relations for normal stress and the shear stress at any particular plane inclined at an angle theta from the plane on which sigma x is acting. Now, if you extend it, let us say if you're applying the shear stresses also, right, over here, then in addition to the this normal stresses over here, then these terms are going to remain same. See, this is the exactly same, and this is also the same. Only difference is going to be this additional term, which is because of this tau xy acting over here. So, right, so these are the additional terms going to be appear over here. And there also I just spoke to you about the how we have to take about the sign, because this was based upon this state of stress. Now, when we are adding this tau xy over here, then obviously you are going to consider again the its effect. So see, if you see this one and this one, these equation and this equation more or less are the same. Only difference being over here sign is positive and sign is negative, right? And that positive negative, how it has come? It has come based upon that these shear stresses that are coming. I am taking this this element over here, this portion, and when the shear stresses are merging at this end over here, and the theta that you are taking basically from the sigma x only, that I have already spoken. And when you are having the tau acting in this direction away from the angle, this angle, and normal is this, then I'm going to have positive over here and negative over here. Now see the situation. If I simply change that direction, let us say if I this is assumed state of stress, right? Now let's come to this point. Let us say instead of that, if I show the state of stress at this point, that is a tau xy, and this way, that is diverging from this particular end over here and over here, whereas this I'm showing only the same direction theta I'm taking from here. In that case, this sign is going to be changed, right? So here it was plus, it will become negative, and here it is negative, it is going to be plus. So based upon this understanding, you are going to have the any numerical that you can solve. So you can just go through that particular video in which I have explained it. If this is clear, then I think you will be able to handle any particular question in this particular topic. Okay, so now let's go ahead and attempt this question on this. So I think I need to show that diagram with the value of normal stress. Okay, so just a minute, I need to bring that my page. So hold on. In the meantime, just read it. Okay, so let me just show it to you. I hope it is clearly visible to you. Right. Okay. So, okay, I'm drawing this diagram. The state of stress which is given to you over here is something this way. Okay, this is the state of stress. on two perpendicular planes of this element have been shown to you, and it says the value of the normal and the shear stress on the plane inclined at 30 degree to the plane on which 180 megapascal stress is acting will be how much. So this is a state of stress which is given to you, and he's saying if you take a plane which is inclined at 30 degree to the plane on which 180 megapascal stress is acting, so what is going to be the state of stress in that particular plane? That means he's talking about what? He's talking about a plane which is inclined at 30 degree to this plane. So this plane is, as you know, this one on which this 180 megapascal is acting. So from this plane, if you take 30 degree, so let us say if I take any plane, so I will show you over here. I will draw it over here again. Okay, so something this way. So you are having this one. So if you take a plane which is inclined at 30 degree to this, so it seems like it is not 30 but something this way. So let's say if this is 30 degree, then it says what is the value of normal stress on this plane and the shear stress on this plane that you are supposed to find out, right? So for that, now first of all you need to simplify this, and this over here he has given you inclination of 30 degree also, that this is inclined at 30 degree. So first of all you need to simplify this. Okay, you know the stress acting over here is 180 megapascal, so I will 180 megapascal, and over here now what I need to do, I can just take its horizontal and vertical component. So horizontal component is going to be 240 into cos of 30, and vertical component is going to be 240 into sine 30. So if you take that value, so it will turn out to be one stress, that is 240 into cos 30, it will turn out to be 213.84 megapascal. And what about the other component? Other component will be parallel to this face. So that means if it is parallel to this face, it is going to be something this way, and this value is going to be 108.95 megapascal. Am I clear? Now point is, until and unless you show these stresses on the planes x and y plane, right? So you will not be able to apply the equations, and you know how we have derived those equations, and it is easy for you. So you have normally taken the theta from the x plane. X plane means the plane on which you are going to have thus the sigma x acting, this plane. So from this plane you have taken this angle theta. So if you can show somehow the stress in this plane, state of stress in this plane, as well as the state of stress perpendicular to this plane, that is a y plane, you can say, then you can very easily make use of those equations that we have. 240. No. It is not coming out. It is already given to you. This is the state of stress given to you. The value of the normal and the shear stress on the plane inclined at 30 degree to the plane on which 180 megapascal stress is acting will be. This is the state of stress given to you. This is the state of stress which is given to you already. This is the state of stress which is you are having, and you are supposed to find out the stress normal as well as the shear stress on a plane inclined at 30 degree to this particular 180 megapascal on the plane on which 180 megapascal is acting. So that is a plane, this horizontal plane, that way, right? So I have simply horizontal and vertical component. If that be the case, now, so my simplified equations are in the form of this simplified relation. So can I convert it? You can say, of course I can do that. What if I do this way? So if I just extend it this way, then you can have that, okay, if it is 180 megapascal, then down there is also going to be 180 megapascal. So it is going to be 180 megapascal. Correct? Now, what about the shear stress? Now, since you are able to find the shear stress on one face, that is sufficient for us to find out the shear stress on the other faces. Other faces, of course, if it is over here, if I take a face over here this way, then in that face, in that phase it is going to be downward. So giving clockwise rotation, anti-clockwise rotation. So to balance it, what I need to do, I need to apply a stress on this phase and in this phase in such a way that it gives me the clockwise rotation, and that clockwise rotation will come when I will apply over here this way. If that is complementary, this way, and definitely it is going to be this way over here. And what will be the magnitude? You will say the magnitude will be the same. Whatever the magnitude that you are having, the same magnitude you are going to have. If that be the case, now what I need the angle theta, because all those equations that you have written over here, you have taken the angle theta from the plane on which sigma x is acting. So that means I need an angle, this angle, that is the inclination from the plane on which sigma x is acting. Sigma x is 213. So that means I need this angle. So if this is 30 degrees, then you can very clearly tell that this angle is 60 degrees. So for me now, theta become 60 degree. This is theta in my equation. So simply what I did is, whatever the configuration that is given to me, I can convert it in my own way as per the, so that I can make use of this equation the way I have derived it. तो मैंने उसको simplified form में अपने form में ले आया. Now it becomes easy for me to apply those equations. That's all. Now what he is asking? He is asking to find out the stress on this plane. So that means he is asking me to find out normal stress and shear stress. But you don't know in this plane, that is in this plane, whether it is compressive or tensile in nature, that you don't know. So I can initially take it as a tensile, and if it turns out to be positive, then I will say tensile. If it will turn out to be negative, you will say it is compressive. Same way, shear stress, I can take any particular direction. I can take this direction initially. Then if, let us say, it turns out to be positive in the calculation, then I will say the shear stress on this particular plane will be in this direction. If it turns out to be negative, it means the direction of this will not be this, but it will be in the other direction. That is the meaning of this, right? So I need to assume this and this nature. I need to assume. Okay. And what will be convenient for us? That is your understanding how you have taken. For example, if you see, when I have applied the stresses over here, okay, whatever may be the compressive or tensile, whatever it may be, but here I have considered the tensile, and tau that I have taken is away from the angle that I am considering over here, away from that. Same way, if you see over here in all the equations, I have considered it away from the angle, tau value away from this, and tau direction away from this. And based upon that, I have written the equation for tau and sigma n. So that means what I will do, since I have remembered all these equations based upon this tau value away from the angle theta over here, then what I can do is I can initially show this tau this way and normal stress this way, which I don't know whether direction is in the same in which I have shown or not. That I will come to know at the end. In any case, that's all. Now it becomes pretty easy for me to apply the equation. Now see, which equation should I apply? You are having shear stress, you are having normal stress. I want to find out these two values. Now see this. Which one is it getting related to? Obviously it is a complex state of stress, either this or this. So now see over here, when I'm taking the element this, if the shear stress is diverging from this point, it is diverging from this point, see. So if it is diverging from this point and tau that I have taken is away from this angle theta over here, I have to make use of the sign. This term is going to be remain same. ये term तो आपका same ही रहेगा, इसमें कोई दिक्कत नहीं है मुझे. This is going to remain same. This is also going to remain same. But only is sign. ये sign क्या होगा? तो यहाँ पर मुझे क्या करना पड़ेगा? In this case, I will take negative and this as positive. Okay. So it means I will make use of this particular equation and my job is done, because I have just converted the whole thing in my own way so that it is resembling this. So now you can just write it cos 2 theta and this. Okay. So what is that value? So now I can write what I need to find out. He has given you the value of normal and shear stress. How you can find out the normal stress? Normal stress is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2, and I think it is cos 2 theta minus tau xy into sine 2 theta. Clear? Now, what is tau xy? Tau xy, you know, this value is tau xy only. So this is what? This is tau xy. That's all. This is sigma x. This becomes sigma y. So I can say this is sigma x and this is sigma y. In all the problems, such problems, you have to convert that problem into a simplified problems, any of these configurations which have been shown to you over here. So it becomes pretty easy then. Then you're never going to have a confusion of angle, confusion of direction and all that. Now, input the value. Keep it in mind over here, when I had written this equation, theta was from x plane, the plane on which sigma x is acting. Sigma x, y were tensile in nature. So if it is tensile, then there is no issue. But if it is a compressive, any of them is going to be compressive, then I need to consider this sign also. Then I need to take the sign of compressive stress as negative in this equation. But here I don't have such situation. So I'm writing this value over here. What is sigma x? Sigma x is how much? Sigma x. You have 213.84 plus sigma xy 180 by 2 and it is going to cos 2 theta. So what is cos 2 theta? Theta is 60, so it is going to be 120 minus what is tau xy? Tau xy is 108.95 into sine again 120. That's all. So what is the value? This turns out to be sigma n coming out to be, sigma n is coming out from here as 88.075 megapascal. Now keep it in mind, see the value of sigma n over here that I'm getting is positive. It means its direction will be in the same direction in which I have shown. That means it is tensile in nature only. Right? That is how I will come to know. Let's go to the shear stress only. Now, how you're going to find out the shear stress in that particular plane? So shear stress you're going to find from that particular plane. See, shear stress is acting, I have taken it in this direction away from this angle theta, and therefore, and these are acting away at this point. So I'm going to take this sign over here as positive, right? Here it was negative when they were converging at this end. So that means tau, the value hai meri, that is going to be sigma x minus y divided by 2, and this value is sine 2 theta plus tau xy plus tau xy and cos 2 theta. So they are not difficult to remember, as you can just see, as I have explained you earlier also, because these terms are not going to change from here. Once this is, if you remember for this, then when you're having complex state of stress, these two terms are going to appear. Only confusion is going to be of plus and minus, that I have made it clear. I have already clarified you in both these cases. Okay, so now just input the values. So you're going to get sigma x is 213.84 minus 180 by 2 sine, again this is 160, that means 120 plus tau xy is 108.95 into cos of 120. So the value that I'm going to get over here is minus 17.57 megapascal. Right? What does it mean? If I'm getting the value of sigma tau as minus value, it means the direction of the assumed direction of the shear stress over here is not right. I need to change its direction. So it means in this plane, the direction of the shear stress acting would be in this direction and not in the direction that is shown to you. That is the meaning of negative sign, right? That's all. So see, most of the problem that you're going to find in this particular topic will be, this part will be simply putting the values only. Only difficulty that you're going to face will be converting this configuration into the usable form, any of these forms. Yeah, either this or this. If you're able to do that, then your job becomes easy. Okay, so if you have understood this, now we can go to the next one. So again, I'm giving the configuration. You have to do the similar kind of exercise. So okay, he's saying this plane, that is, let us say this is plane AC, right? And he has given that angle as 30 degree. Okay, this is the state of stress. The value of shear stress on the plane AC for the given state of stress is megapascal. Okay, so you know it very clearly. If I want to find out the shear stress at any particular inclined plane, then you need to know the value of what? Sigma x, sigma y, and tau xy. These three values you need to know, and theta. Now see, you know over here sigma x, which is compressive in nature. You don't know the value of sigma y. So to find out the tau over here, I need sigma x, sigma y, and tau xy. Tau xy you already know, because in one phase he has given you the value of the shear stress. If I know that, on other phases I can find it out very easily. Not find out, you know, it is complementary in nature, you can get it done. So now simplify this. That's all. How you can do that? So you can do it very easily now. So let us say this is how it is. So I'm extending it this way. So you're already having 100, 50, and this become my tau xy, or where tau yx, you can say whatever you want to say, xy or xyx in this direction I can show. So over here you are having 40 kilonewton, and this 40 kilonewton is what? You know, this value is sigma n, which is given to you. Normal stress acting on the inclined plane at 30 degree from the x plane. Theta is equal to 30 degree. And what do you want to find out? I want to find out tau. So over here, I don't know. Shear I can show. Shear, you know, shear will be either converging at two ends or diverging at two ends. This is how it is going to be. See, if it is forming clockwise, if it is these two are forming clockwise, this is going to be anti-clockwise, right? So it means this is going to be this way. So should I show it this way? You are having tau xy, which is going to 50, and I don't know what? I don't know sigma y. Let us assume that this sigma y is tensile. I have assumed it, right? So it will turn out to positive. It means it was correct. If it will turn out to be negative, then I will say it is acting as a compressive over here. Same way, now what I need to do, I have almost simplified it now in my own version. Now I need to show the shear stress, and as we have taken all those equations based upon a shear stress direction shown in such a way that it is diverging from this angle which we have taken over there. So I am showing the direction of shear stress assuming, not showing, rather I'm assuming the direction of shear stress at this particular plane as tau, which I want to find out. Now tell me, can I find it out? So I want to find out what he has asked me to find out tau, this tau. So how I can find it out? Because now this relationship is this one, positive over here. So this is going to be this way. So they are converging, and over here it is this way. So these two relation, rather this is what I am supposed to find out, right? I have to use that relationship, right? And since I don't know this sigma y in this example that we are talking about, so but he has given me the sigma n value. So since he has given me the sigma n value, so I input that value from this equation. I know sigma x, I know theta. I will be able to find out the sigma y. So find out the value of sigma y from here, input that value over here, and your job is done, right? So I'm writing this equation. Okay, so what is that? This is second one. Sigma x plus tau is equal to sigma x plus sigma y by 2. I think it will be minus, right? Sigma x minus sigma y by 2, and it is cos 2 theta or what? Sigma x minus sigma sine 2 theta and minus tau xy cos 2 theta. So have I used this sign properly or not? You can just see minus, it is minus. So you can see it. Yes, this is converging over here. So minus sign. Okay. That's all. Now what I need the sigma y. So for that I need to calculate. So also, sigma n equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2, and it is what? Cos 2 theta plus tau xy sine 2 theta, right? So this is what you have. Now just input this value. Okay, so now what you do is input the values of x. Now you have to keep note of one thing over here. Sigma x is compressive, so it means you have to take the value of sigma x as negative. Clear? So it means sigma x you have to input in as a negative value. Tau xy already given to you. And one more thing, sigma n shown to you over here is compressive over here. So it means sigma n also you need to input in this equation as a negative value. So these are the two things that you have to keep in mind over here while inputting the values. One is the sigma n at this plane given is negative, which is compressive, and sigma x is also negative. Okay, one more confusion I think you can have in this direction of the stress. For example, this out of way, just to give you an idea that you can face this kind of situation also. For example, let us say if I say the same situation, but instead of this 40 kilonewton I have shown this way. If I show this way, if I had shown this 40 kilonewton this way on this plane, is this force compressive or tensile in this plane? This force, is it compressive or tensile in this plane? You will say this looks like the direction is same, so this is also compressive. But no, this is tensile, because when I am showing anything on any particular plane, it means when I am showing compressive, that means if it is compressive, that means at this plane, if it is compressing this plane from both sides, that is the meaning of this. So if I had to show from the other side, then I will show the stress in the force in opposite direction on the same plane this way. That means this way I can show it. But over here, if you see, it is pulling this plane. If it is pulling this plane this way, then it means in the other direction it will be having this way. So it means if I'm showing on the same plane, if I'm showing the force this way, it means this is not compressive, this is tensile, because it will be pulling this plane this way. Same way over here, if I'm showing this way over here, it means it is compressing this particular plane. So it means this will not be compressive, but this will be tensile. So it means the interpretation of this will be this one. Like it is something like same way. For example, if you're showing a compressive stress on this plane, it means this plane will be getting compressed from both sides. And if you're saying that it is a tensile, had you shown it as a tensile, it means this plane is getting pulled from both sides. So it means this way, right? That is the, I think, one point that you have to keep in mind. Okay. Anyway, now just input the value. So sigma n, as I told you, is negative compressive. So it is minus what? 40 kilonewtons. So minus 40 equal to, what is sigma x? What is sigma x? Because sigma x is also compressive. So it is minus 100. What is sigma y? Sigma y is, you don't know. So as of now, I'm taking it as a tensile only, because in this formula also they are appearing as a tensile. But if it turns out to be negative, then it will be compressive. Plus, what is sigma x? Minus 100 minus y divided by 2 and cos 2 theta. And you know, this angle from x plane is going to be 60. 2 into 30 plus tau xy is 50. I'm correct. Am I correct? Let me just cross check. Have I shown it this way only? 50 only, right? And sine of 60. That's all. So what is the value? From here, if you will solve it, you're going to get the value of sigma y, and that turns out to be negative. And sigma y will come as what? Minus 5.145 megapascal. It means the direction of the normal stress that I have shown over there is not tensile, but it will be compressive in nature. That is the meaning of this. But anyway, now I came to know this value. Now, when I have to input the values of sigma x and sigma y over here, I have to take the sign of both, right? Since I have got the value of sigma y as negative, so I need to input the value of sigma y as negative only over here. Now, so go ahead now. So now you are having, so it means actual state of stress is this way. This is actual. That is the meaning of this. Anyway, just input the value over there now. So tau, you're going to have sigma x is how much? Minus 100, and sigma y minus sigma y. So sigma y is negative. So you have to do is minus 5.154 divided by 2 sine 60 minus tau xy 50 and cos 60. That's all. So you have to take this value. So you have to take note of the sign, and this value also turns out to be negative. Tau will be equal to minus 67.758 megapascal. So what does it mean? It means that the actual state of stress over here will be sigma y will be compressive, sigma x is compressive. So in this plane also you are having sigma n as compressive, whereas direction of the shear stress that I have assumed earlier will be in opposite direction. So it should be, I think you got the value of minus 28. 28 for what? Why it is coming out to be 28? It will turn out to be negative. Everything is in front of you. You have the formula 60 60. If I am correct, it is 50 over there. And since here you have to take the sign, this was of sign, minus sign is of formula, whereas you have to consider the sign of whether this is compressive or tensile in nature. So this formula is based upon the assumption that sigma y I have applied is tensile, but actually it is negative. So I need to input the value of negative. So it will be, total will be, this will be positive. So this is how you are going to get. Okay. So this question I had taken deliberately in order to make you understand the nature, how you need to take the value of these sigma x and sigma y if they have been given as a compressive and all that, right? Because the equations that you have derived over here is based on the considering the tensile nature of this sigma x and sigma y. Okay, let's now move ahead. So I need to draw the diagram also over here. So this is the element given to you, and you have stresses acting this way. This is 8 over here and 3. 8 megapascal, and you are having 3 megapascal. And over here also, he has given you in the inclined plane direction of shear stress, as well as he has given you 2 megapascal. So it becomes 2 megapascal, and it is 3 megapascal. And here he has given us 45 degree. Right? So now again, you have what? Again, bring it to your own configuration. इसी configuration में लेके आना है आपने. You have to bring it to this whole configuration. इस configuration में लाने का मतलब नहीं है exactly यही नहीं है. मतलब ये है कि you should have that the inclined plane. You have to get the angle of that particular plane from x plane. So that x plane could be this or this. As well as you have to take that value of the shear stress. You have to show the value of the shear stress or direction of the shear stress away from that particular angle, and rest ये x और y, tau xy, you can just get it done anyway. अच्छा, अब इसको मैं complete करूं. Let us say if you want to see it, you just see it this way. Let us say if I complete it as a okay. Let us say if I show it this way. Right? Since inclination has been given to you this way. So for me, x plane is either this or this, meaning is same. Either it is left or right. It is up to you. Since I know this one, so can I say this is this way? So I know the angle. If this is 45, this is 45. So it means if I take this angle from here, theta, from x plane, which is either this or this, so you know this angle now. You know this is 8 megapascal. You know this is 8 megapascal. So if it is 8 over here on the same plane, x plane, you have 8 megapascal. So I will write it 80 only. You have this. Okay, you have shear acting on this plane, x plane, as 3 megapascal over here. So if I take it on the other side, then obviously if it is downward, it is going to be upward. So tau xy over here is how much? It is 3. So it is 3 only. Now what I need? I don't know this x and y on this element now. I know but that on this inclined plane, which is this one, you have 2 megapascal and 3 megapascal. 2 megapascal is tensile. If you see this plane, 2 megapascal is tensile. So if I have to represent over here, if I am considering this element, then it will be tensile. How I have to show the tensile? So I have to show the tensile this way. So it is 2 megapascal. And what was the shear? Because if you don't get confused over here, I can combine them this way. Half this way. And if I take another half this way, if I take another half this way, then obviously force balancing, right? X की जो forces हैं वो balance हो रही हैं. आपने कहा ये ऐसे this way, I said this way. Now when we come to this plane over here, if you are showing on this side of this element, if you are showing this as tensile at 2 megapascal over here, then on this face, if I have to show the tensile, then it has to be opposite to this direction of this. Only I can say this is tensile. I cannot show on the same on the same face, but on the opposite element or on the other side this way. If I show it this way over here, then it will be compressive over here. So I want the tensile over here on this side. So it means on this element over here, it is getting pulled that way. So it means it is going to be tensile. What about the shear? If you are showing shear this way on this plane, then over here it is going to be in opposite direction. So if you see, if you have shown it this way on this side, then definitely over here you have to show it on the other side. So it will be this way. So now you're both this one and this one has matched, right? So either you do that. It's the same thing that I have done over here. Only thing is I clubbed it and now I'm showing it. But meaning is this, right? So I have to take it. If it is tensile, so it is tensile on the same plane. If I, because I will be considering this element, right? So then you are having this. So that means this is 3. Done. That's all. Now my job is done. What I am having, I'm having this element, that is this element now, because from X face I can show you the angle which I have this, and rest other forces and stresses are also over there. Now tell me what is going to be the Y face. On Y face, what is going to be the value of this shear stress that you can show always, because if it is acting this way, so it is producing the clockwise movement. Now to counter it, I have to show it this way. So that means if it is this way, so I over here I need to apply this way. So it means this is going to produce anti-clockwise. So it was producing clockwise, anti-clockwise. So you came to know the direction of shear stress, which is 3 in magnitude, on the Y face also, or the face perpendicular to the sigma Y, you can say. And now what is sigma Y, that you don't know over here, right? So for that, what I need to do? For that, what I need to do, I need to assume it. So you assume it, there's no issue. So let us say I'm assuming it is tensile over here. That's all. So this is tau xy. This is tau xy. This is sigma y, sigma x, and sigma y I have taken. Rest, you know, this is sigma n. This is sigma n, and this is tau. Now tell me which equation you are going to use. That is the important point now. Which equation you are going to use? If I had taken the equation, just remember those equation now. From x plane angle theta, I was applying what? I was applying sigma x, sigma y. Now, what about the shear? In this case, from this corner, where they are perpendicular, these two faces are perpendicular, from there, shear stress is diverging. It is going away. So it means diverging. And the direction of the shear stress that I have shown you over here, or given to me, is away from this. From this corner theta, that is this corner theta, it is going away from tau. This is the same configuration. So now when you're taking this element, left side element, and this element situation is same. Only thing is you're considering it on this side, where my equation is that I have derived is based upon considering this element this way, but exactly same interpretation. Okay, so now you can make use of that equation that you are having over here, diverging, and this is coming out this way. That means diverging and coming out this way. What is that? This is diverging, coming out this way. So that means this equation I need to make use of. That's all. That's all. Okay. Okay, so then if that be the case, then it becomes pretty easy now. So what I need to find out, because I want to maximum minimum principal stress is given. So maximum minimum principal stress, from where you're going to get, you know, this is the maximum minimum principal stress. So it is sigma x plus sigma y by 2 plus minus sigma x minus sigma y divided by 2 square plus tau xy square. I need tau xy, which I know. Sigma x and sigma y I want to know. Sigma x I already know. Sigma y I want to find out. For that I have been given the sigma n. So what you do also, you know, you will say for this configuration, sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2. What is that? Cos 2 theta, I think. Cos 2 theta. And it is minus tau xy sin 2 theta. Just input the values. Pretty simple. I think the values are also simple. So x is how much? X 8, tensile in nature, plus sigma y I don't know, divided by 2, plus sigma x 8 minus sigma y divided by 2 cos 2 theta. How much is that? 90. It will come cos 90. Sorry, 45 90. 90 will become 0. Cos 90 will become 0, and this will become 1 minus 45, that is 90, become 1. Tau xy is how much? 3. And sigma n is tensile over there, so it is 2. Pretty easy. So from there, sigma y I can find out. What is that? 8, 4 minus 3. 4 minus 3, 1. I think it will turn out to be 1. I am committing mistake or not? I don't know. Somewhere I may have committed mistake. 2 cos 90 to 4. Okay, yes. I committed mistake over here, right? So it will be 4 minus this 3, 1. It goes there 1, but also sigma y by 2 is also over there. So 0.5, right? So it means it is a 0.5 sigma y. So you can say it will become 1 by 0.5. That means 10 by 2. That means 2 megapascal. And this value is coming out to be positive, right? So I got the value of sigma y as 2. Okay, so now rest is just simply I don't need to go for tau. I don't need to make use of this because directly I am able to get the sigma x and y. Tau xy I know, which is acting over here. So directly sigma 1 2 will be equal to what? Sigma x is how much? Sigma x 8. So 8 plus 2 divided by 2 plus minus 8 minus 2 by 2 square plus tau 3 square. So it will turn out to 9, 3, 6 by 2, 3 square, it becomes 9 plus 9, 18. So it will become 5 plus minus under root 18. 8 plus 2, 10 by 5, 5 plus 3, 3. Okay, good. So that means I'm going to have sigma 1 as 5 plus under root 18. Under root 18 will turn out to be 4.424, that all that. So it will turn out to be 9.2426 megapascal. And when I will take the negative sign this over here, so it will be 0.7574 megapascal. Okay, clear? So that is how we have to find out. So only thing, the challenge that you find for yourself. So first, just what you can do is you can practice some similar kind of questions on the similar lines. Only try to, this part you will be able to configure. This part you will be able to do plus minus sign, that original formula that you are having. Only thing is that only practice that you have to do is converting any kind of configuration given to you in the form in which you want it to be. So either this side or that side, that is up to you. Once that is done, I think your job becomes pretty easy, right? So that is how you have to attempt these questions. Okay, so let's go to the next now. Over here, he says the state of 2D stress is given to you. So the state of stress that is given to you is sigma xx, sigma xy, sigma yx, and sigma yy. This is the matrix of stress for plane stress system, that is 2D, 200, 50, 50, minus 40. So this is given to you megapascal. Okay, so that is what is given to you. And now you are supposed to find out what? You are supposed to find out or maximum principal stress and maximum shear stress respectively, right? So for that you already have the formula, right? Directly you can make use of that formula, how to find out the principal stress and shear stress. So I think we use the formula, same formula just now over here. This is the way we want to find out the maximum value of principal stress. So maximum value of principal stress means sigma 1 part I want to find out. So I will use the plus sign only. So just input the value and get it done. And when we talk about the maximum value of shear stress, that means this portion is the maximum value of the shear stress for any complex state of stress. So if I say what is sigma x, as you know, over here this is sigma x, this is sigma y, and this is shear stress. Sigma xy equal to sigma yx. So this is a shear stress. So it means, can I say I'm having sigma x as 200 megapascal, and I'm having sigma y as minus 40 megapascal. And what about the shear stress? So you can say tau xy or tau yx, meaning is same. Tau yx equal to 50 megapascal. Am I clear? So it means if I want to find out the principal stress, so sigma x plus sigma y by 2 square plus tau xy square. Simply input the values and you will get the result, and that result would be, simply because you don't have to even, because okay, so one thing that you have to take note of the sign. So I'm writing it for the sake of your minus y, 440 divided by 2 plus, so over there it is 200 plus it is going to be 40, right? Minus minus plus divided by 2 square plus tau 50 square. So that value turns out to be how much? It will turn out to be 80 plus 130, and it will turn out to be 210 megapascal. Okay, and what about the tau max? Tau max is this part only, so which is 130 coming out. So that is sigma x minus sigma y divided by 2 square plus tau xy square under root, and which is equal to what? 130 megapascal. Okay, that is how we have to approach these problems. So I hope may have been a good session for you. So see you in the next session. Today we could take only these much questions, because there's a next session and another mentor is going to take. So see you in the next session. Till then, bye. Thank you.